Okay, I'm back. Video number 2. I wanted to erase this and then make sure we have room for the next thing. So just to remind you about valence electrons, okay? Valence electrons are the electrons, like I said, that were in the outermost energy level, the outermost energy level of each element, okay? So for example, if you recall, hydrogen's configuration is 1s1. That means it has one valence electron, okay? Lithium, on the other hand, has an electronic configuration of 1s2, 2s1. So for lithium, because it ends in that's the erasure. Because lithium is 1s2, 2s1, that means its outer energy level is energy level 2. It has one electron, so that's one valence electron. And the same is going to be true for every element in that group. Like sodium, which I'll do in red so it stands out a little bit more. Sodium, for example, is 1s2, 2s2, 2p6, 3s1. Okay, so again, it has a different configuration, but its outer energy level is number 3. It only has one electron in that third energy level, so it also has one valence electron, okay? So that trend is consistent by group, okay? So in terms of valence electrons, which I'll write on here, okay, and you know the abbreviation for electron is E with a minus sign, okay? So for valence electrons, your alkali metals have 1. Your alkaline earth metals have 2. We're going to skip the transition metals because the D sublevel comes into play here. That becomes a little more complicated. So we're going to just ignore these for the time being. We will reach a point in the year where we'll talk about them a little bit more. But again, going back to your main group elements, which are the tall columns, okay, the boron group has 3 valence electrons, carbon group has 4, nitrogen group has 5, oxygen group has 6, halogens have 7, noble gases have 8, okay? That's how you can remember. They just go in order 1 through 8 with the tall columns, okay? Again, is that something you have to have memorized? The answer is yes and no. Like, everything's going to go a lot faster for you if we can just figure out off the top of our head, like, okay, nitrogen has 5 valence electrons. Then when we start drawing molecules with the nitrogen in it, we're able to just move on from there as opposed to taking time to try to remember what the valence electrons are. Okay, so just try your best to brush up on these over the summer. Okay, I do want to take a little time to talk about charges. Same thing. Okay, like I said in the last slide, the last video, although I didn't go all the way across. Your alkali metals are +1. Your alkaline earth metals are +2. Again, ignore the transition elements because they kind of have their own situation with charges, okay? Your boron group for metals is typically +3. The carbon group for metals, okay, because keep in mind, we're talking about charges relate to ionic compounds, okay? Ionic compounds are between a metal and a non-metal. So in a lot of these cases, like carbon, for example, is a non-metal. It's usually not involved in ionic compounds, but if it is, it would have a negative charge. However, I'm going to go back to pink because it's easier to see. Like in your carbon group, you have lead and tin, which you definitely know are metals, okay? Like you've seen those before. Those metals typically have a +4 charge, okay? And then when you get to the nitrogen group, you really have, a lot of non-metals. So we'll go -3, -2 for the oxygen group, -1 for the halogens, and then typically your noble gases don't have a charge because they have the 8 valence electrons that they need. Okay, so that should give you the rundown of the periodic table.